Number 8, an ellipse centered at the origin has a vertical major axis of 12 units and an eccentricity of 0.5. What is the equation in the ellipse? Well, here in a second I'll show you how to do this purely with the calculator. I want to remind you, if it's centered at the origin, that means up with the x and y, there will be nothing in parentheses. So I can't eliminate anything. All 4 of these options are eliminated or centered at the origin. Next, we have a vertical major axis. That means the longest side is vertical. That means the value under y will be bigger than the value under x, and it's 12 units long. Well, the vertical major axis is always 2a, which means that the a is actually 6 units. So that means underneath y we would have 6 squared. So this one's gone, and only these 2 remain. And it says it has an eccentricity of 0.5. Now you need to remember that eccentricity comes from the formula c divided by a. Now in this problem we just discovered a is 6, and we don't know what b is, but we have 2 options. I'm going to choose this one first. This might be b squared. If b squared, let's just say if b squared equals 9, then b equals 3. Now what's the relationship between a, b, and c? C squared equals a squared minus b squared. So in this case, you would say we have 36, we can subtract 9, which gives me 27. Now if that's the case, that when I take the square root here, c will be the square root of 27, and so I'd put that over a. Is the square root of 27 over 6 equal to 0.5? Well, no. What's equal to 0.5 would be 3 over 6. So this option is definitely not correct. So this should be wrong here. And now we'll try this one. And, you know, we could go about this a different way as well. I'll just say 0.5 has got to equal c over a. And we know that our a is 6. So I'll put that there. Multiply both sides by 6. I get 3 equals c. And if 3 equals c, then if I go back to this formula of c squared equals a squared minus b squared, and this time I put in 3 there, so 3 squared equals 6 squared minus b squared, I can quickly find out that if c, all right, that's 9, this equals 36. When I subtract that 36, what's going to happen is I'll have negative 27 equals negative b squared. Otherwise stated, if I multiply everything by negative 1, positive 27 equals b squared. And that's what we have there. So that should be our equation. Now let's check it in the calculator, because I said we could do this from the get-go just using the calculator. How I graph this is I'm going to go to New Document and choose a graph. I'm going to go Menu, Graph Entry, and I'll choose Equation. From here, I go down to Ellipse. Here's my equation. Now, I don't have any shifts, so I'll put a 0 and 0. We're saying that this was a 36, and the calculator already throws in a squared. So you can put a 6 there, or if you don't want to risk messing up any numbers, just put what they showed you, just put it with the square root, because a square root and a square will cancel. So I'll do that the same thing here. I'll put square root 27. I enter. Now there's the shape. Now from here I can go to Menu, Analyze Graph, Analyze Conic, and I'll just choose the information they gave me. They said that the major axis was 12 units long. So I look on here, I don't see that. I do see eccentricity, so I can first click that and see that it is 0.5, so that's accurate. Now I'm going to put down there, when I go back to Analyze Graph, this time what I will choose is just axis of symmetry. And when I see this, now I'm just going to count along these lines. Now this doesn't matter because it's already on the y-axis and x-axis. It's centered at the origin, but if it wasn't, it would be helpful. But we just need to count. The major would be the longer side. So this one is 1, 2, 3, 4, 5, 6 up, and 1, 2, 3, 4, 5, 6 down. So it's 12 across. So we do see that the major axis is 12 units long. I could count this way and see this is a little bit past. Let's see, 1, 2, 3, 4, 5, and a little bit more. 1, 2, 3, 4, 5, and a little bit more. So this one is not 12 units. It'd be closer to 11 units long, not quite 11. So anyways, that's how you can do it in the calculator.